This next category of problems are problems where you just need to remember something or know some math fact. And so for problem number 3, it says at most, how many obtuse angles can a triangle have? So if you're aware that there's such a thing as an obtuse triangle, you know that it can have at least one. And then if you remember that an obtuse angle is greater than 90 degrees and less than 180 degrees. So an obtuse angle, something greater than 90 but less than 180. And then there's different ways to realize that there can only be one. If I have two obtuse angles, even if it was just a little bit more than 90, these sides are never going to meet up to make a triangle. You can't have more than one obtuse angle. If you think about it, if they're greater than 90 degrees, two of them would be already greater than 180. No matter what it is, even if it's 90.1, it's greater than 180. And your three angles of your triangle have to add up to 180 degrees. So you can only have one obtuse angle in a triangle. The same way you can only have one right angle in a triangle. How many integers from 10 to 100 are squares of integers? This is just about knowing your perfect squares. We don't need any squares less than 10, so 9 after 9 is 3 squared. 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared 49, 8 squared is 64. It might on the test be more efficient to not even write these down and just realize, okay, 10 squared is 100. Oh, it asked for how many? Excuse me, we should really write them down. 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared 121, 12 squared is 144. Maybe it's faster in a test setting to say 4, 5, 6 and just realize you don't even have to write down the exact perfect square until you get close to the 300, but 13 squared 169, 14 squared 196, 15 squared 225, 16 squared, I should know this, 256. You can use a calculator on this test. So 16 squared, you have 256. 17 squared is 289, I think. And I'm fairly certain 18 squared goes over, but as long as I can use a calculator, let's just check. Yeah, 324. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it should be answer choice A. If we did it right. Yes. Okay, problem number 28. If a circle's area has the same numerical value as the circle's circumference, the diameter of the circle is, and we have these answer choices. So the thing you need to know on this problem is are the formulas for circumference. Circumference equals pi times diameter. And area equals pi r squared. So if the diameter equals 4, circumference equals pi times 4 or 4 pi. Area would equal pi times, well, r must be 2 if d is 4. So pi times 2 squared, which is also 4 pi. And we get lucky and it's the first answer choice. If we had enough time at the end of the contest, which you almost certainly won't, but if you did, you could check these others. C equals 2 pi and A equals 1 squared pi, which is 1 pi. B doesn't work. For C equals 4 over pi times pi, which would just be 4. And area equals pi multiplied by 2 over pi squared, which is pi times 4 over pi squared, which is just 4 over pi. Well, if 4 does not equal 4 over pi, you're going to get something similar for D. Answer choice A is the correct answer. Number 33, 2 to the 2017th power multiplied by 1/4 to the 1008th power. The thing you need to know here is that in a problem like this, it's a properties of exponents problem, so you really need the same base. I have a base of 2 here and a base of 1/4 here, but 1/4 is the same as 2 to the negative second power, so we can rewrite this as 2 to the 2017th power multiplied by 2 to the negative second power to the 1008th power. A power of a power, you multiply the exponents. So this is 2 to the 2017 multiplied by 2 to the negative 2016. And then when you multiply with the same base, you add the exponents. 2017 plus negative 2016 is just 1. So 2 to the 1 is 2. So answer choice B. Lastly, Anil, Bell, and Jack found many golden eggs. Notice A, B, and C. So I'm going to make a table. A, B, and C. For every 5 eggs that Anil found, Bell found 4. So there's a 5-to-4 ratio between Anil and Bell. For every 5 eggs that Bell found, Chalk found 6, so a 5-to-6 ratio between B and C. They must have found a total of at least how many eggs? The least common multiple of 4 and 5, they share no common prime factors, so it's just the product of those two, 20. So the scale factor here is 4. I apply that scale factor here, and I get 24. The scale factor from here to here is 5. Apply that scale factor to A, and I get 25. So the least amount of eggs they could have found is 20 and 25 and 24, which is 69 eggs. Answer choice C.